Welcome to another video of the tutorial series on Resource Modeling Solutions Automated Modeling Platform, AMP. Here, we'll dive deeper into some of the visualization tools available in AMP. By the end of this video, you'll be able to confidently set up your visualization scenes so you can make the most out of your data. Starting from the Recent Projects page, let's open the short-term modeling workflow example project. Let's go down to the Scene menu. You'll see we have a scene called Overview. We've covered details on how to create a new scene in the previous video of this tutorial series. Let's click in View Scene. In the Scene menu, we have a few general options. We can duplicate the scene and delete the scene. We can also choose to show or not the coordinate axis and toggle the color bar on and off. With the color bar, we also have a drop-down list of the resources available in the scene, and we can pick which color bar we want to show. So in this case here, we're showing the color bar representative of the drill holes, but we could also be showing blast holes and so on and so forth. Down below we have the resources list that are available within the scene, and for convenience, let's pop out the resource menu. There are some options for each resource contained in the scene. We can remove that resource from the scene, we can toggle visibility on and off, and pop out the menu of each resource. Let's inspect the resource list menu. In this scene, we have 4 different types of data loaded. We have point data, interval data or drilling data, a solid, and a grid. Each resource type will have their own visualization options. Let's toggle the visibility off from all resources except the blast holes data. Let's start with the point data, the blast holes. Expanding the blast hole, we see something called level of detail. The level of detail is an option to make visualizations more efficient. In the blast holes data, for example, if we decrease the level of detail using the slider, we'll note that not all data points will be shown. We'll also see a notification highlighting these resources being visualized with a lower level of detail. And this is not a particularly large data set, so we can keep the maximum level of detail. For point data, we have 2 representation options, spheres and points. With spheres, you can choose a radius, and with points, you can choose the point size. Let's go back to the spheres representation. We can apply transparency using the slider over here. And you can set filters. For example, let's filter our blast holes copper grades greater than or equal to 200 ppm. If you hit enter, you apply those changes straight to the scene. We can add another filter. For example, let's filter the geology to be within certain categories. For example, 223, 424, and 276. Again, hit enter to apply those changes. I can choose to enable or deactivate both filters at once, or each filter individually. I can also choose to color the data points by geology and interpret this as categories by checking this box and apply those changes to the scene. AMP will automatically map the values from the geology columns as categories. Minimizing the blast holes now will show there is a filter applied to this data. We can always close this pop-out, and this information will come back to the scene menu as it was originally. Let's pop out the resources menu back again and color my data points by copper again. Let's also remove the geology filter. Note that the copper variable has some variable parameters that are set by the project parameter file being used in our MSP workflow that is attached to this project. If you're familiar with our MSP workflows, you know what I mean by the project parameters file. Clicking on the copper here will take me to the variable parameters menu. We inspect this more closely when we introduce the connectivity between AMP and our MSP. Going back to the scene menu, let's hide the blast hole data and bring in the drill hole data. Drill hole data can be represented as points, lines, and tubes. And we can choose their sizes in the corresponding slider. The remaining options are quite similar to what we've just covered for point data. Now let's hide the drill holes and show the LVA searches, the solid we have loaded in the scene. Solids have three possible representations. They can be shown as a surface, surface with edges, and a wireframe. You can set transparency for all representations, and we can choose colors. Now let's hide the LVA searches and show our block model or our grid file. For grids and block models, the level of detail can be important, especially if you have subgrid data or large grids. Note that if you decrease the level of detail when visualizing grids, you see an upscale representation of those grid nodes or blocks. No operation is being applied here. This is simply a visualization effect. Similarly to the solids, you can visualize the blocks as surface, surface with edges, and the wireframe or the block contours only. The remaining options are again very similar to what was discussed for point data. Let's go back to representing our blocks as surfaces, and we could quickly set up a filter for the ordinary kriging estimates of my copper grades. We're visualizing only the estimated copper grades larger than or equal to 200 ppm. Now we can inspect these blocks against the blast holes using the same filter for an initial visual validation. Let's show the LVA searches again. Let's visualize them as a surface and decrease the level of detail. Remember to check if there are any notifications on the resources in the scene. For example, we have filters applied to the blast holes and the block model, and the LVA searches here are being visualized with a lower level of detail. Now let's revert back to some of the original visualization options. Removing the filters so we can visualize all of the blocks and blast hole data, and toggle the visibility of the LVA searches off. Now let's inspect the slicer tool. Let's add a slice to the scene. We can choose a slice orientation. Let's choose the azimuth option, and then let's pick an azimuth of 135. Let's set the slicer to move every 10 meters. And we can choose between unsliced, front slice, back slice, or thick slice, as it is the case here. We can set the slice width as well. Both the slider or just typing in the value here work. Let's set it to 20 meters. And we can also specify parameters for each resource type individually. Let's choose the drill holes here and let's set them to be unsliced. And now we save this slice to our overview scene and we're able to visualize the slice. Let's also toggle the visibility of the drill holes on so we can see them unsliced as we've just set on the slicer. And then we can step through the slices every 10 meters as previously set. We can quickly edit this slide to show a plan view. Let's save the changes to the scene. Let's remove the drill holes for a second. And then we can quickly visualize our estimated blocks against our input blast holes data on plan view as well. In the next video, we'll talk about workflows in AMP and connectivity with RMSP. Thanks for tuning in. We hope you picked up some valuable tools and tricks for data visualization. Now it's your turn. Dive in and start visualizing your own data and projects. If you have any questions, our support team is here to help.